Hello students, today's class we are going to study power electronic devices. That is nothing but Thristor family devices, different types of Thristor family devices. So after the completion of this class you will be able to know the different types of power electronic devices, their symbols and after this we're going to study one of the thyristor, that is a gate turn of SCR, and also the ratings of the SCR thyristor, that is SCR rate, thyristor rate, SCR ratings, and also the gate turn of SCR. Coming to the concept of power electronic devices, power electronics deals with the conversion, control, and switching of electric power. So here it finds three important applications, three areas of applications: conversion, control, and switching of power, electric power, in the industry and also in the domestic applications. So they are going to use in by wave shaping of voltage, current, both voltage and current, and also they will be used as a switching devices, thyristors. So what is a power electronic system? Power electronic system is first we have an electric supply, that is source, and then we have a power electronic circuit or device, so that is a converter control device, so that may convert or control the electric power, and after that we have a load that will be used by this converter or controlled voltage. So the load may use this controlled voltage or the converted supply. So advantages of power electronic devices. So the different advantages are, there are different types of advantages of power electronic devices, namely high efficiency due to low loss, because the on-state loss is very low, on-state resistance is very low, so therefore the on-state loss is very low, so therefore efficiency is very high due to low loss, and high reliability. You may get the same type of operation at any time at a rated voltage, and long life, and it requires less maintenance. Coming to electromechanical switches, comparing with the electromechanical switches, small size, they occupy small size and less weight, and low cost, and fast dynamic response. So these are the advantages of power electronic devices. Applications of power electronics devices. Coming to the applications, so we may use these power electronic devices in the domestic applications, residential, that is residential applications where cooking, in the cooking, micro ovens, also controlling of micro ovens, cooking appliances, lighting, and space heating, dryers and refrigerators. We are going to use these thyristors. And transportation, we may use these street cars, it may be used in trolley buses and subways we can use. And telecommunication, they may use as a battery chargers, power supplies, etc. And in commercial, advertising, heating, air conditioning, and UPS, etc. Uninterrupted power supplies. So we'll see the classification. Power electronic devices, they are broadly divided into two types. Power semiconductor device or thyristors are divided into two terminal devices and three terminal devices. In the two terminal devices we have a pin diode and a Schottky diode. Whereas 3-terminal device we have the power MOSFET, JFET, IGBT, BJT and thyristors. And again, so pin diode is a magnetic carrier device. Its conduction depends on magnetic carriers. And Schottky diode, power MOSFET and JFET depends on the majority carrier device. Again, IGBT, BJT and thyristor depends on minority carrier devices. Coming to the different types of the thyristor family devices are SCR, diode, triode, silicon unilateral switch, silicon bilateral switch, get turn off SCR, G2 SCR, LA SCR, light activated SCR, asymmetrical SCR, reverse conducting thyristor, static induction thyristor, silicon control switch. These are the different types of thyristor devices. First we'll see what is a silicon control rectifier. Silicon control rectifier is a 3-terminal device, anode, cathode and gate, and the symbol you can see here. The construction and operation later we will see. This is the symbol of silicon control rectifier. It's the most important device in the thyristor family. The construction of other semiconductor devices in the thyristor family are very similar to the silicon control rectifier. So if you know the operation of this SCR, so the other thyristor operations are very similar except with small changes in the construction. So we have small changes in the operation. Almost the operation is similar, but with the small construction difference we have a small operational changes in the other thyristor device. So if you understand well the operation of SCR, then it is going to be easy for to understand the operation of other semiconductor devices. So coming to the di-AC, 2-terminal bidirectional conducting thyristor, that is a bidirectional diode or a thyristor. Here the name because it is bidirectional, so it can conduct from T1 to T2 or T2 to T1. So when T1 to T2, when the T1 is made more positive than T2, and T2 to T1 it conducts the current when T2 is more positive with respect to T1. Triode, 3-terminal tri-AC, that means 3-terminal bidirectional conducting device. 3-terminal bidirectional conducting device. And the 3 terminals are the T1, T2 and the gate. So comparing with the diode and comparing the triode with the diode and SCR, when comparing the triode with the SCR, so triode and SCR both are 3-terminal devices, but SCR is a unidirectional conducting device, whereas the triode is a bidirectional conducting device. Comparing with the diode and triode, both the diode and triode are bidirectional devices, but the diode we don't have gate and the triode we have a gate, so we have a control over the operation of the triode, but in the diode we don't have the control over the switching on the diode. And gate turn off SCR, so it is one more type of SCR. So in the SCR the turn off is not possible once it enters into conduction. So for turning off the SCR we need an external circuit, that is commutating circuits are required. So to avoid that commutating circuits we are going to use a gate turn off SCR. This is the difference between GTO SCR and SCR. Commutation circuit is not required in the GTO SCR, whereas the commutation circuit is required in the silicon control rectifier. Silicon unidirectional switch, so here the symbol anode, cathode and gate similar to the SCR. Silicon unilateral switch, unidirectional switch. but we have one schematic. We can see one GNA diode connected in anti-parallel, so that it can be protected with a reverse. It will be protected with a high reverse voltages. Silicon bidirectional switch. So two silicon unidirectional switches connected in anti-parallel, that makes the silicon bidirectional switch. Silicon control switch. It is going to have two gates, anode gate and cathode gate. So we have a cathode gate for the SCR, but it is similar to SCR with one more gate at the anode. So in the SCR can be turned on with the positive voltage, but here the silicon control switch can be turned on by a positive and negative voltage. A positive gate voltage at the cathode gate and a negative voltage at the anode gate makes the silicon control switch and enters into conduction, makes the SCR into on. Or similarly, a negative voltage at the cathode gate and a positive voltage at the anode gate makes the SCS, silicon control switch, into on. Simply, so we can use the positive, and it can operate both positive and negative voltages. We can turn on and turn off the silicon control switch with the positive and negative voltage. Light activated SCR, LESCR. So here the light is made to fall on the reverse bias junction J2. So it is going to provide some more charge carriers. Electron holes pairs are generated with the by falling the light on the reverse bias junction. That is going to reduce the reverse bias, so the device enters into conduction. So this is the LESCR. The triggering is a light pulse, light with certain intensity is made to fall on the reverse bias junction in the LESCR. Asymmetrical SCR, one more type of SCR, reverse conducting thyristor. So it is going to conduct in the reverse direction SCR. Silicon static induction thyristor, and these are the different types of thyristors. So these are the figures, thyristor symbols, actual figures of the thyristors. Coming to the summary, power electron deals with the efficient conversion and control of electric power for various applications. Any 4-layer device, PNPN, is called a thyristor family device. Commonly used power electronic device is a SCR. So coming to the questions, small question, number of junctions in a thyristor is that is SCR is a 3. Which of the following is a unidirectional device? Silicon unilateral switch is a unidirectional. The questions coming on this topic are draw the symbols for different thyristor devices, explain the constructional details of silicon thyristor family devices, list the thyristor family devices. Now we will go to the thyristor ratings. Ratings of the thyristor ratings. before that we will study the GTO SCR, gate turn off SCR. So after the completion of this, we are going to we will be able to know the constructional details of GTO SCR, turn off action, structure of GTO SCR, and the VI characteristics of GTO SCR. Advantages, disadvantages of GTO SCR, applications and GTO SCR, comparison between GTO SCR and SCR. So we will see the symbols of GTO SCR. Here the arrow inward and outward. So that is inward arrow makes the SCR into on, and the outward arrow makes the SCR into off. So this is the symbol of GTO SCR. It has three terminals: anode, cathode and gate. GTO SCR is turned on by applying a short positive voltage gate pulse, and it can be turned off by applying a high amplitude negative gate pulse. Constructional details: it has 4 layers and 3 terminal device. GTO SCR. It is a PN device with 3 terminals, namely anode, cathode and gate. It can be turned off by applying a negative gate pulse. It can be turned on by applying a positive gate voltage. No forced completion is required. No external circuit is not required for making the SCR into off. The turn off action of GTO SCR. How turn off action? The current gain of PNP transistor is very low. So therefore, if the gate signal is negative, a negative gate signal is given. So therefore, excess carriers are drawn from the base region of the NPN transistor. So because of the negative voltage, the base is NPN transistor. P is the base is of P type. So the majority carriers which are present, that are holes, will be moving away from the base towards the gate. So therefore, the majority excess carriers, that is majority carriers, are drawn out of the base region of the NPN transistor, and the collector current of so therefore it enters into off state. So NPN transistor goes off, and the current collector current, therefore the collector current of PNP transistor is diverted to the gate. So base drive of NPN transistor is removed, which in turn removes the base drive of the PNP. So when the base drive of NPN transistor is removed with the negative gate voltage, so it enters into off. So this will turn the PNP transistor also into off. So this is called a regenerative operation. So the collector current of NPN transistor is the base current. So there is no base current, so therefore there is no collector current for the PNP transistor, because IC is equal to beta times of copy. So both the transistor enters into off state. Turn off is achieved. Structure: this is the structure of GTO SCR. Structure of GTO SCR. This type of structure has simultaneous turn on and turn off operations. The reduction of gain of the PNP transistor is obtained by introduction of anode to N base short circuiting spots. Anode to N base short circuiting spots. N plus, so it is N base short circuiting spots. these are the anode to N base short. These are short circuiting with this N plus regions. So that is going to reduce the current gain of the PNP transistor. The structure has a low on state voltage and the ability to block the reverse voltage is poor. Large GTOs have integrated gate cathode structure in which the cathode emitter consists of many parallel connected N-type fingers diffused into P-type gate region. N-type fingers diffused into P-type gate. So the VI characteristics of GTOs are similar to the SCR, very similar. It has a large value of latching current. If the gate current is not able to turn on the GTO SCR, then it behaves like a high voltage low gain transistor. It has a low power loss. Gate losses are very small, so it is going to have a very low loss device. It is a low loss device. Advantages of GTO SCR comparing with the SCR: small size, less weight, high efficiency. Comparing with the SCR, losses are minimized. There is no commutating circuit, so therefore the losses are minimized. High efficiency, no need of commutation circuit. Fast switching speed comparing with the SCR. Lesser noise due to elimination of commutation circuit. High withstanding capability of surge currents. These are the advantages of GTO SCR comparing with the SCR. The disadvantages of GTO SCR or the SCR are: high gate current is required to make the SCR into conduction, GTO SCR into conduction. High magnitude of latching current holding current. High gate circuit losses. High on-state voltage drop comparing with the SCR. Lower reverse voltage blocking capability. These are the disadvantages for GTO SCR comparing with the SCR. Applications of GTO SCR: they are used in electric traction. They are also used in adjustable frequency inverter drives, used in rolling mills, and used in machine tools. Comparison between GTO SCR and SCR: the efficiency is high in the GTO SCR comparing with the SCR. Noise is less in the GTO SCR comparing with the SCR. Gate current is required more in GTO SCR. Gate current is required less in SCR. Size and weight: it is small. GTO SCR is small and SCR is large. So we have discussed about no forced communication circuit. No forced communication circuit is required in that to turn off the GTO SCR. Automatically it goes into off when we apply a negative gate pulse to the GTO SCR. In this fast, we have a faster switching speed, high gate circuit losses, and high current gain of the PNP transistor is low. Current gain of the PNP. Advantage designs of applications of GTO SCR we have studied. So coming to the commercial GTOs currently have ratings of up to voltage 2.5 K, 1.5 kiloamperes. GTO SCR turn off achieved in the following condition: current gain of PNP transistor is very low. Which of the following statement is regarding the GTO SCR is true? Smaller size, less weight. Which of the electronic device produces less noise? GTO SCR having low noise. GTO SCR can be turned off by applying a negative gate pulse. So questions coming on the topic are: draw and explain the turn off action of the GTO SCR. Explain the VI characteristics of GTO SCR. What are the advantages of GTO SCR and the disadvantages of the GTO SCR and applications of the GTO SCR. So one more important topic, that is the ratings of SCR. We will see today the ratings of Thristor ratings. Ratings are safety working margins which are little bit higher than normal working values. So for any device we have as voltage and current rating, we should not operate above that rating. So before operating using the device in the circuit, we should know the ratings of the any devices. So because the power devices, thyristors are used in high voltage and current applications, we should know the working voltage of safe working voltage of voltage and currents of thyristors. So these are called ratings of the SCR. So SCR is the most widely used device in the thyristor family. So we should know the ratings of the SCR. So for reliable operation of thyristor, we should not exceed the safety working margins. So for reliable operation and safe operation, we should not move, that voltage should not exceed the value of the rated voltage and current. So we should know the ratings, otherwise the thyristor gets damaged. Classification of the ratings, their SCR ratings are classified into three types: continuous rating, repetitive rating, non-repetitive or surge rating. Continuous rating. Continuous rating, these ratings are related with the continuous working condition of the device. Repetitive rating is useful where the device is switched on periodically, repetitive rating, and when it is going to use the switch periodically. And non-repetitive or surge rating corresponds to the maximum permissible non-repetitive current and peak voltage which the device can withstand during the sudden change. So that is called a non-repetitive or surge rating. General thyristor ratings actually are, so the device specifications are anode voltage rating, current ratings, power ratings, di by dt rating, dv by dt rating, turn on turn off times, latching and holding currents, and temperature ratings. So the above ratings will be specified by the manufacturer of the thyristor or SCR. We will see one by one. The anode voltage rating, so that is the voltage which is required to make the device into conduction. Anode forward voltage, it indicates the maximum voltage that can be applied to the device without causing any breakdown at the junction area. So this is called as anode voltage. Current rating, there are different current ratings established with repetitive and non-repetitive waveforms. Current should be not raise the thyristor junction temperature even for short overloads of current. If the junction temperature increases rapidly, the thyristor will be damaged. Hence the operating current should be within the limits for safe working of the device. So current ratings are very important. Turn on time, time taken by the thyristor to reach the full conduction. It consists of delay time and rise time. T on is equal to Td plus Tr, namely T on is equal to Td plus delay time plus rise time. Turn on time of SCR between 2 to 10 microseconds. So it is the delay time, the 0 to 10% of the value, that is delay, and from 1% to 90% of the maximum, it is called as rise time. dV by dt rating indicates the maximum rate of rise of voltage from anode to cathode without any harm to the device. And the di by dt rating indicates the maximum rate of rise of current from the anode to cathode without any harm to the device. Turn off time: when the reverse voltage is applied to the thyristor, the time taken from zero current point to time when the thyristor regains its full blocking voltage is called turn off time. Turn off time consists of reverse recovery current time and also recombination time TR. So the turn off time is the reverse recovery time plus the recombination time. The circuit turn off time must be greater than the device turn off time for safe turn off. First the device should get off, then only the circuit should get off. Turn off characteristics: these are the turn off characteristics. Temperature ratings: coming to the temperature ratings, the thyristor junction temperature rises rapidly even for short overloads of current. Hence, heat is developed and dissipated in the form of power. For satisfactory turn off thyristor, the junction temperature under steady state condition should not exceed the safe value, which is usually 125 degrees. So these are the temperature rating. And coming the summary: for reliable operation of thyristor, the device should be operated within the specified limits. These safe limits are called the thyristor ratings. Turn on time of the thyristor is of the order of 2 to 10 microseconds. Turn off time of the thyristor is between 50 to 200 microseconds. It takes more time to turn off. Coming to the quiz questions, some questions. Turn off time of an SCR measures from the instant anode voltage and anode current become zero at the same time. For safe turn off SCR, the circuit turn off time must be greater than the device turn off time. The frequently asked questions, coming questions in the examination are: what are the different ratings of the thyristor? What is the classification of thyristor ratings? Define turn on, turn off time of SCR. Draw the turn on, turn off characteristics of the thyristor. And lastly, we will see some manufacturer data sheet of the power electronic devices. So the study after this, the manufacturer data sheet of power electronic devices. So this is the manufacturer data sheet of a typical OE1600 series type of thyristors. So as mentioned, RMS value of the total current, RMS value of the voltage, forward voltage, gate triggering voltage, gate triggering current, and rating, the limiting of the above series and are as per conducting state. Maximum forward voltage drop is junction voltage 250 degrees centigrade, and maximum forward voltage is 3 volts on state voltage. Average on state current is 10 amperes. Holding current value is 40 milliamperes. Average on state power dissipation is 25 watts. peak reverse blocking current is 7 milliamperes. Peak forward blocking current is 7 milliamperes. Full cycle average reverse blocking current 2.5 milliamperes. Full cycle average forward blocking current is 2.5 milliamperes. And coming to the gate parameters, maximum gate triggering current is 70 milliamperes. Maximum gate triggering voltage is 3.5 volts. We should not exceed that voltage. Average gate power is 0.5 watts. Coming to the thermal temperature characteristics, operating junction temperature varies from -40 degrees centigrade to it can vary up to 100 degrees centigrade, plus storage temperature range -40 to 120 degrees centigrade we can store, and case temperature is -60 degrees centigrade. Effective thermal resistance is 1.2 degrees centigrade per watt. Switching parameters, rate applied voltage dV by dt is 20 volts per microsecond. So in 1 microsecond it can stand with 20 volt change in the voltage from anode to cathode. dI by dt 20 amperes in 1 microsecond. Mechanical parameters are stud torque 30 libs lbs per inch, pounds per inch. We have discussed about the data sheet of power electron device. Some question coming on the topic is power electron. Give some power electron device with their ratings and specifications. So in this class we have studied different Thristor family devices. Then we have studied the GTO SCR. After that we have studied the Thristor ratings, different ratings of the Thristor, and also the manufacturer data sheet. So now we will conclude this session today.